talk to me about the sample efficient deep reinforcement learning paper that you
Yeah, so this one is a little bit more technical, but it's very cool, and I thought I'd bring it up here. So this is a paper from DeepMind. Came out in the last couple of weeks, or at least I stumbled on it then. And it's a change to a reinforcement learning algorithm, specifically in the case where there is a simulator available. And
Tell
reinforcement.
me more about what a simulator is.
So it means that it doesn't need to go out necessarily in the real world to gather all of its data. So it has some, let's take that robot farmer or grape counting,
your grape counting
one that we talked about ages ago. The real world version of that is drive through some grape fields. The simulated version is I'm going to throw some grapes on a vine, render it in a 3D engine, and use that data captured in the rendered environment to do my reinforcement learning. And, even in those contexts, gathering data for reinforcement learning is slow because you need to go through a whole bunch of different scenarios. If you think you're playing Grand Theft Auto in a reinforcement learning, you've got to, play a lot of games before you get good. This paper has a slight change in the way it gathers different scenarios. So it has a different method to replay certain scenarios from its history that have the highest amount of uncertainty. So any of these reinforcement learning algorithms, they'll do a bit of work, estimate what the reward of doing a bit more work would be on a number of different possible trajectories. So imagine chess. It'll try and make a guess of all the pieces it can move. If I moved them, how good is that outcome going to be? And it'll have a certain amount of confidence in its estimates. Typically, it'll just say, anyway, go with the strongest expected value and go down that line. What this work showed is that if you can reset the simulator and replay some of those high uncertainty scenarios in that simulated environment, you can get much, much better reinforcement learning with fewer plays. So less games of chess by just rewinding the board to a certain stage and just playing just a little bit in a bunch of different directions.
Oh, and so that would really, really quickly screen out those where the AI has an absolute brain melt and does the wrong thing kind of scenarios a lot quicker. So for example, if you were driving a car and it just decided to suddenly veer left on a straight road.
Yeah.
Because that was a very uncertain event, it could go back and realize that was incorrect, play that a couple of times, learn on that, and then not do that brain fart moment again.
Exactly. So this particular algorithm, or this change in training, so they use, deep Q networks, a pretty traditional set of reinforcement learning networks, but with this slight change, it manages to do a lot better in some historically very complex scenarios like Atari games. So there's this notoriously hard Atari game called Montezuma's Revenge. AI used to be quite shit at it because it was just too complex for it to really learn good patterns of behavior. But with this change, it's been able to achieve superhuman scores in that no human will ever get as good as the AI now at this notoriously hard Atari game, which I thought was really cool.
This is what excites me about the space so much as well. It's just one of the things, we're going to be able to get rid of small innovations like this that are just chipping away at the problem.
Yeah.
Are compounding every week at the moment. It's great.
Yeah, definitely, man. And I think the cool thing here is it's a big play towards efficiency and training efficiency. And in the world of, mega models with mega data sets, if you can get the same results with less data, that means with the same amount of data, you should, hopefully, in theory, be able to get better results.
Yeah.
So, yeah, very keen for that one. Check that one out. It's very cool if you're in the reinforcement learning space. I'm sure we'll see some good applications of that soon.